encouraging discussion this evening, which leads me swiftly on to our speakers. So we have two speakers joining us this evening. The second of those I'm going to introduce first. So that's Judith Leary-Joyce, who joins us from St Albans. Judith has become an expert in retrofit. When we say retrofit, we mean improving the thermal efficiency of existing housing stock. So not new build properties, but upgrading old properties. Judith, like us, lives in a conservation area, St Albans, not subject to the same scheme of management as we have here, but nonetheless a conservation area. And she, like many of us, started out on a journey wanting to do her bit for the planet and improve the thermal comfort of her home. Realised that there actually wasn't a lot of information out there, or certainly not all pulled together. She informed and educated herself. She did her own retrofit. She's now written a book about it, a kind of idiot's guide, if you will. And she has several copies at the back that you're welcome to have a look at towards the end of the session if you wish. So thank you to Judith for joining us. She's going to give her presentation shortly after Dermot Barnes, who is our other speaker, who joins us geographically even closer to home. He is from the Muswell Hill Sustainability Group and also is a director of XCO2, which is a building performance consultancy. And Dermot is an expert in building performance and retrofitting, and he's going to give us a presentation now on how to retrofit our properties in a professional and well-managed way. So Dermot, over to you. Thank you so much. Would you like a microphone?
Yeah, thank you very much. So good evening, everybody, and thank you so much for this invitation this evening. It really is heartwarming to be part of a conversation like this. This is a courageous conversation. It's not an easy conversation, and I'm just so delighted there are so many people here talking about this evening, wanting to find solutions. Some of those pioneering and some of them challenging, but nevertheless, it's a fantastic opportunity to start to push some of the boundaries that we need to address. Now, just before I jump into things this evening, I want to start by saying two things. The first is that what I'm going to speak about is a vast area, both in breadth and depth. So I'm not going to be able to cover it all as you would all like it to be covered. So that's a preemptive apology on my part. Sorry, I'm going to try and do that. Is that better? About the right distance? Thank you. So a preemptive apology. I'm going to cover everything I can, but very quickly. Any one of the subject areas that I'm going to speak about would be deserving of a good hour, and I've got 15 minutes to do everything. So yeah, I hope you'll bear with me. So what I'm going to hope to cover, there'll be a brief introduction as to who I am and why it is we're having this conversation. That will lead us into looking at energy use in buildings, retrofit methodologies, and risk assessments. Rather tedious stuff, but tremendously important. I'm then going to speak about some of the elements of a building and how they might be treated depending on the individual building. I'm going to talk about the residual energy demand, which is the energy that your building still needs even after you've done all of the energy efficiency, the fabric and demand reduction stuff. I'm going to then speak briefly, just point to a couple of reference case studies and just wrap up with some key takeaways. So just to put it in context, the company that I work for is a 50, now almost 60 strong company of engineers. As Sarah suggested, we specialize in building performance. Approximately 50% of us are engineers and perhaps the other 50% are architects. We're working more and more with retrofit solutions for a wide range of customers and clients. Some of that is traditionally the new build stuff that you have to do when you're building a new development, but it spans all of these different areas of work. I'm going to scoot through this stuff, but just so that you know there's a context and a body of knowledge. behind what I'm speaking about. The kinds of customers or clients we work for, this is a short list. Most of these are in the sort of social housing space. Somewhat ironically, given people's financial abilities, it's a truth that social housing is often more energy efficient than private housing. A very brief introduction to the planetary context. We all know that, well, we will all have heard that we're running at about 1.1 degrees above pre-1990 levels. That's today. We have committed to 1.5 degrees, or worst case, 2 degrees. I'm not going to go into what that means and what life will be like when we hit 1.5 degrees, but just to say that everything we are doing at the moment needs to be done about 5 times the speed that it is currently being done at, if we are to stay within 1.5 degrees. That's why what we're doing this evening is so important, because we've got a big part, each one of us have got a part to play in the solutions. So again, bringing this back to buildings, as Sarah was saying, there's a huge elephant in the room, and the biggest and most challenging elephant to move. It's that 30% or more, when you look at other building types, of energy that is wrapped up in building use. And time is running out. We have a situation at the moment where if we are to meet our obligations under the Climate Change Act, we would need to do 25 million comprehensive retrofits in 30 years. And that's basically every house that was built before 1990. And if I tell you that we're still building houses today that will need to be retrofitted, it's even more terrifying, but that's also a fact. And just to translate that massive figure into something a bit more immediate, that means 833,000 homes a year, or 1 every 40 seconds. So you might well ask, what are we doing here? We should be at home retrofitting. I mean, you know, the urgency is enormous. Now, I want to speak briefly about some of the other challenges. This is very, very brief again. If we continue the way we're going, we will hit 3 to 4 degrees. That's business as usual. And what that really means for us is that our buildings will need to be adapted to a new climate reality. So you might think the biggest challenge is how to keep the heat inside your home, but increasingly the challenge is going to be how to keep the heat outside your home. And if you look at the bottom right-hand corner, there's a tiny little graph, which I appreciate you probably won't see terribly well there, but it basically points to a heating versus cooling balance, which is not far away from us. The Climate Change Committee, which Chris Stark is chair of and has advised the government and continues to advise the government on their obligations under the Climate Act, has pointed to the fact that instead of needing more energy for heating our homes, that's actually predicted to come down by 6.5%. But what we will need by 2035 is another 5% of energy to cool our homes. I'm not going to comment too much on this. I just think it's an enormous social injustice that we, as a country with the 6th biggest GDP in the world, in the 21st century, we have a large slice of our population who have to go home and wonder whether they should pay for food, rent, or heat. It's, you know, almost criminal in my view that is the reality so many people have to face. And it's something that needs to change. Our homes need to be affordable to live in. This is a pointer to the fact that although we're talking about operational carbon, when we talk about net zero and we talk about 2050, there's more to it. We need to think about the carbon that goes into our buildings in the form of the materials we use. And whereas this is largely a consideration for new buildings, it's increasingly important in our own existing buildings that we think about the materials we're using and the cost, the carbon cost of those materials. So, moving on to the nuts and bolts. This is just a very brief pointer to the fact that the two biggest elements that we need to tackle are heating and hot water, which collectively represent about 80% of the energy we typically use. Now, every home is different. Yours and mine will be different. The guy with a swimming pool will clearly have a different bill to mine. But the rest of the equation, the 17 to 20% for lighting and cooking and so forth, it's important. We have to attack that as well, but primarily we need to look at space heating and hot water. So when we think about space heating, that's the sort of 66%, two-thirds of what we need to look at. This is an analysis, a very old chestnut from the Energy Savings Trust, which just points to how we lose heat in our buildings. The sort of easy one that is always referred to is the roof. Around about 26% typically goes through the roof. So, direct translation there is a very large chunk of your energy, the gas you're consuming or the electricity you're using for heating, is literally going through the roof. So insulation in the roof, which I'm going to come to in a moment, is part of that. So the rest of the equation is as you see it. Walls are a good 33%, and all the other ingredients make up the balance. So there's a recipe, or a number of recipes, for how we retrofit a building. This is a pointer to the fact that there are a huge number of approaches and methodologies. When we do take on a retrofit project, it is helpful in all but the most basic interventions. It is really helpful to approach it systematically and look at it holistically. So at the very top here, you see a thing called PAS 2035. That's a methodology which I'm going to recommend you actively consider for any significant retrofit projects that you're going to undertake. So that one there, I'm going to focus on and go into in a little bit of detail. So this is a risk assessment methodology. So I want to ask a very quick question here. Does anybody have any idea why we would need to use a risk assessment methodology when retrofitting a building? Does anybody have a gut feeling? Just stick your hands up if you do. If you don't worry. It's not a problem.
It needs the heat and the cold, and it can also harm the house if we do it wrong.
It can indeed. It can harm the house, exactly. If you get it wrong, it can harm the house, and it can harm the health of the people in the house. So, very, very briefly, this is a list. Now, I can't go through all of them. We don't have enough time. But, there's issues around getting it wrong, spending a heap of money, and not delivering the energy savings and the cost and the energy cost savings. But there's also issues about indoor quality, indoor air quality, building fabric deterioration, mold growth, wet rot, dry rot, all kinds of things that can go wrong, including effects and impacts on human health, which are very considerable if you do get it wrong. People have died from mold growth in buildings, so it's a serious issue, and it does need to be considered. So this PAS 2035 methodology sets out a number of approaches to building, and as I said, it's risk assessment based. So what happens is your building is determined to be high, middle, or low risk, and a whole methodology is set up to reflect that. It sets responsibilities and roles with an assessor, a designer, and a coordinator involved in assessing the work, value judging it, and safety or risk judging it. It assesses the existing condition, and it recommends demand and reduction energy efficiency measures and residual energy strategies. So in terms of how it does that, or in terms of the outcomes, it aims to give you what's called a medium-term improvement plan, so a sequenced order of work which will be bespoke to every property with capital cost and payback and kilowatt hour and CO2 paybacks. It makes sure that your regulatory compliant, and it employs a fabric-first approach so that all elements are considered. And it also provides a registered record of the work that's been done, which can, when you come to sell your property, be accessed by future buyers. And at the end of it, you wind up with something like this, which I appreciate you can't read at that distance, but essentially it gives you a capital cost, a carbon cost effectiveness, and a disruption matrix to consider a series of different interventions, and indeed a combination of those interventions, so that you get the best value for money. And say, for example, you're going to change your kitchen in 5 years' time, there would be a sequence which would include work to allow that to happen, so you're not undoing and redoing things. So I'm going to move on to the next stage, which is the elemental approach. Very quickly to say, lofts and roofs, that was the sort of 25-30%, the first thing that was on that slide I showed you earlier. So here the approach is very simple. On the left-hand side, you're working essentially between and above joists, or ceiling joists mainly, and then on the right-hand side, a more complex approach where you're insulating in line with the roof. Now, there are serious implications for ventilation in roofs, and where you position and how you position your insulation is crucial to maintain airflow where it needs to be and keep it away from where it doesn't need to be. Quickly on to floors. Lots of different approaches with floors, but that sort of schematic on the left-hand side is showing you a kind of a build-up which basically suggests insulating between the floor joists using an air tightness membrane across the top, and then putting a taped flooring boarding down on top of it. Now, if you move to the pictures on the right-hand side, you can see an air tightness membrane is going in as a carrier membrane in this case, and it's carrying, in this case, a warm cell, which is a recycled newspaper insulant, and then there's an air tightness tape, that green tape that you see all the way around the circumference or the periphery of the room, which keeps the drafts out as well as keeping the heat in. Solid wall insulation. So I know external wall insulation is very firmly frowned upon in the suburb for understandable reasons. I won't dwell on it. It is the better solution if you can do it instead of internal wall insulation. But lots of different approaches. Again, I'll sort of keep them very brief. This middle one is looking at internal wall insulation, and it's pointing to what I'm calling a vapor open construction. That essentially means that if you've got internal wall insulation, the build-up of around about 30 litres of water, which accumulates in the average home per day, so through our normal living experiences in a home, around about 30 litres of water per day is released into the air and the atmosphere in our homes. So that has to go somewhere, generally out of the building. So what you try to do with a vapor open construction or a vapor permeable construction is allow that moisture to find its way out of the building, rather than trying to keep it inside and then mechanically ventilating it, although mechanical ventilation is often, in any case, necessary. Now, vapor closed has been, as a methodology, has long been used. It is now increasingly realized to be the wrong way of doing things, and it's a very high risk path if you do use it. So that this photograph on the top essentially is showing an insulation inside a stud membrane, on top of which there is a vapor control layer, which is essentially a vapor barrier in this case, which is a plastic bag, for want of a better term, plastic membrane. Huge risks of penetrating that and moisture getting into the fabric to create what they call interstitial condensation. So lots of risks around that, and happy to talk about that later, big subject. But very briefly, that's what can happen, and that's when you're lucky, because there you see it. Very often you don't see it. It's behind the insulation, and that's when the real fun starts. So what can we do about that? Okay, well, air tightness is very closely related to ventilation and the means by which normally moisture gets out of your building. So in a typical building around here, there'll be lots of nooks and crannies and cracks and openings everywhere that will let the air and the moisture, let the cold air in, it'll let the heat out, and it'll also let the moisture out, which means generally you don't have too much of a risk. But as soon as we start to insulate and or make our buildings more airtight, we change that moisture balance, and that is where a risk can occur. So the ways in which we do that is by putting in place a ventilation system. So building regulations, which would be one of the things you need to consider, will dictate that you've got to have, under Part F, you've got to have a ventilation system that creates 30 litres of fresh air per second per person in a normal home, and in a home where there are smokers, it needs to be 50 litres per second per person. So, moving on very quickly. Residual heat demand, this is going to be super brief. I know you guys are probably all experts by now on air source heat pumps. You've had the talk. I just want to sort of point out two things. Very often this gets glossed over. So the coefficient of performance, which basically is the ratio between the energy going into a unit and the energy coming out of it, is about 0.9 with gas. So that means you put in 1 kilowatt hour of gas and you get out about 0.9 of a kilowatt hour. So there's a 10% loss roughly, if that's a modern, efficient condensing boiler. Best case about 93%. The coefficient of performance of, and there's a typo here, apologies, of the ASHP is 1 kilowatt hour in to about 2.5 or 2.8 out. So that sounds great. You put 1 kilowatt hour of electricity in, you get 3 out. It isn't quite that simple, but that sounds great. The only trouble is, the trouble is that energy, electrical energy is much more expensive than gas, so there's an issue there. But these are my top tips if you're considering air source heat pump. Don't do it unless you've got a major program of retrofit undergone in your home and you found ways to reduce your energy demand. Otherwise, you're going to find your bills will go through the roof. May not be a concern, but for most people it is. Second thing you could do is have a solar PV array. That will help because it's using electricity and contributing some of the electrical load to run your air source heat pump. And it's just a final warning, you know, it's nearly 4 times. So it's about 45 pence per kilowatt hour at the moment for electricity versus about 13p for gas. 2 last elephants in the room. The more we do around our building fabric, the more important the unregulated energy is. And when we speak of unregulated energy, we're talking about all that stuff that isn't heating, hot water and cooling. It's the cooking, the plug load and so forth. That remains an increasingly large percentage of the energy the more you do with the heating load. So it's an obvious one, but people forget about it. And when we're trying to get to net zero, we have to target that. And at the moment, the government doesn't do that through building regulations and EPCs. And perhaps the last thing just to say is that when you look at all of the things you need to do, and even when you employ professionals to help you, there's still a huge performance gap. So we have a lot to learn as an industry, the building industry, the construction industry in particular. Typically, you design to maybe, in this case, 20 kilowatt hours per square meter per year, and it can be up to 70 kilowatt hours. So there's a factor of 3 or 4 gap between what we're trying to do and what we're doing and what's actually happening. Very, very briefly, on to some case studies. So this is just a point. The reason I've chosen these 3, these are case studies that XCO2 have worked on, projects of ours. And the only reason I've got them here is to simply say there is no reason, even with an Article 4, even with a Grade 2, because 2 of these are Grade 2 listed. The right-hand one, Belsize Fire Station, is Grade 2 listed, Grade 2 star listed. You can still do amazing things to reduce energy consumption. You can get it down by 50, 60, or even 70%. So there's no real excuse to not do it. it can be done, and I would encourage those who can think about this from a strategic point of view to do so. Two final slides. This is an example of a study we've just done for the Peabody Trust, where it is heritage buildings in Pimlico. They're mostly 1860s, 1870s, 1880s, and some of them are Grade 2 listed, and some are simple heritage, and some are Article 4. It's a mixed bag, about 6,000 units across their estates that are made up of these types. And there are all sorts of solutions, which are sometimes fabric-based, and sometimes fabric plus energy systems-based. So when you look at a net zero ambition, some of the opportunities there are around decarbonising the energy system that tenants or home users can occupy, or access, I should say. This is another example of a similar one we're doing for the London Borough of Hackney at the moment, not listed, but similar sort of systems approach, where you're looking at it strategically from the point of view of the energy system as well as the building fabric. I won't dwell on this one. These are just examples of some homes that have been done, typical red brick homes, where we weren't able to do external wall insulation, but still delivered about a 50% energy saving. These are projects that were done with public funding in the borough of Sutton. So lots of good news stories, which we can speak about later. So key takeaways, very conveniently located in the middle of the pipe there. The key things just to remember is that every pre-1990 home will need to be substantially retrofitted. That's yours, mine, and Buckingham Palace as well, I guess. The net zero can't simply be achieved by buying green energy, so plugging into ecotricity does not do it. And I can speak to you about why it doesn't, but anyway. Everyone has a role to play. The solution to this is not government, the solution to this is not you or me, it's everybody working together. It's not the trust, and yes, it is the trust. It's everybody working together to find solutions strategically. And please remember, you need a fabric-first, whole house approach. And last but not least, there should be no insulation without ventilation. Now, there's lots of different approaches. They don't need to be whole house approaches when it comes to ventilation systems, but you do need to ventilate. So, lastly, a very quick question for you. Can anybody tell me the single most important measure we can all take when we are at home to reduce our carbon emissions? I mean, this is a very simple question and a very simple answer.
Turn down the heat of your boiler.
Yeah, fantastic. It's so obvious, it's so simple, but many of us go and spend a fortune retrofitting our homes and then leave the temperature at 22 or 23 degrees, run around in our underwear. That's not the solution. It is making sure we don't need the energy in the first place, making sure it's warm and cozy so that we need less energy from the national grid. So that's me. Sorry, it was a very short and quick run through things, but hopefully that's covered it.
It's going to be much more low-tech now. My name's Judith Leary-Joyce. I live in a 1901 Victorian end of terrace in a conservation area in St Albans. And 2 years ago we completed a retrofit. We did it because we cared about the earth. Actually, we care about our grandkids and your grandkids, and are they going to have a life to live? So I'd heard the statistic, it's along the same lines of what Dermot was saying, 22% of all UK emissions come from leaky homes. So it seemed like this was the obvious way forward, was to retrofit our home. So we've now had 2 winters, and I can tell you that we are much warmer than we ever were in our leaky old bucket of a house. And we are saving 75% of our energy usage. We've been through that figure so many times because we didn't expect it. We were hoping, when we worked it out, it would be 50%, but it's 75%. We've worked it out on kilowatt hours because money obviously isn't much use to us at the moment, but that's a lot of energy saved. So what I'm going to do is I'm going to very quickly talk you through what we did, how we did it, and what are the differences it's made to us. But first of all, let me give you a bit of a context. I think you will see. Is my one up there? Thank you very much. So we've lived in this house for 43 years. I think they'll carry me out of there in a box. It's a great house. We've done masses of work to it over the years, but this round of work began with the conservatory. I'm sure some of you have them, or maybe you can't have them here, I don't know. It's one of those conservatories on the back of the house, freezing in the winter, too hot in the summer, delightful. Today would have been perfect in the conservatory. But we wanted an all year round room, so we decided that we would take it down and build on the same footprint, build an all year room. I was a bit bothered when I have a husband who, why bother with one idea when 10 will do? We keep going around different possibilities. Why not take out the wall between the kitchen and the new room? Which sounds great, because our kitchen was really dark, and it was too small for me. I'm an avid cook, so I didn't have the space. So I like the idea, but I've never been very keen on open plan living because I think it takes a lot more energy, and it's energy that we often don't need to use. So the compromise, after many years actually of trying to work this out, was that we would get an eco-architect and have an eco-build for this extension. I'm ashamed to say it took a long time before the penny finally dropped. There's no point in having a beautiful eco-extension stuck on the back of a leaky bucket. So we had a long, dark night of the soul discussion and finally came to the conclusion we were going to go back through the house, we were going to keep going, we were going to retrofit through, and we were going to make this house a legacy so that we could live lightly on the earth and anyone that followed us could live equally lightly. So that was what we did, but of course we'd started just to build an extension, so we didn't have eco-builders. They thought we were bonkers, frankly. What we'd done already they thought was really a bit weird, but never mind. They were good builders and they turned up every day. So it then meant that I was sitting in the midst of all this mess, because we lived in the house through the whole thing, on the internet, trying to understand what is it we've got to do, what's the order we have to do it in, what things affect each other. I was reading endless papers that I understood about this much of, Googling everything, finding professionals that were willing to talk with me and help me understand. So finally I came down to a very simple, please excuse me tonight, feels terrible to say these things in front of a professional like this. I came to down 5 things that we've got to do. First of all, we've got to insulate, clearly. And when you think about it, what you're doing when you insulate, you're just making a bigger barrier between the inside and the outside. So if you think of it in terms of a metaphor that I've used a lot in my own head, it's like you're going out for a walk on a really cold day, and so you put on a warm jumper. That's your insulation. You wrap the house in a warm jumper. Then you have to look to air tightness, because I learned very early on that if you just insulate but you don't do air tightness, you're going to end up, your feet are going to be just as cold as they always were, and you'll feel disappointed and think, oh, it wasn't worth doing that. So air tightness, to me, is like doing your draft exclusion on speed. You are looking for everything, every little hole that is letting in uncontrolled air, and you're closing it up. So that's like putting on your windproof jacket over your jumper because you've started off down the road and you realise the wind's going through the gaps in the knitting. So you've now got your warm jumper and your jacket. And so that's your insulation, your air tightness. So now you've got a nice tight box that you're living in, but you've cut out all of the uncontrolled air. And I was reading, as you do, building regulations recently, and apparently what they're now saying, since 2022, that you need as much ventilation afterwards as you had before, which was a lot in our house. So if you think about, stick with the metaphor of your jacket, by the time you've walked a bit, you're starting to get a bit warm. So if your jacket's breathable, a bit of the vapour you're producing can go through the jacket, but then when it gets really hot, you've got to undo the zip and you've got to let in some fresh air. So this is what we then had to do in our tight seal of a house, which would be disastrous if we did nothing. We built using breathable materials so that vapour, breathability, this is a craziness in building. Breathability is about vapour. Get your head around that. So you've got to let the vapour go through all of the building materials and then put in ventilation. So then once you've got your tight seal and you've cut out your uncontrolled air, you've got in your controlled air, then you can start thinking about how are we going to heat it. And for us, that was an air source heat pump. We'd love to have had ground source, but it wasn't possible. And also, as Dermot was saying, can you get PV in somewhere? I know that's difficult for you. We managed to get some in, and it does help quite a lot. So those were the things that we realised we had to do. So how did we do it? Pretty much like Dermot's picture about the insulation, we insulated inside. We helped ourselves by taking out chimney breasts in one of the rooms, which gave space. But we put in 100 mil of insulation. So upon the Victorian brick, we were putting breathable airtight membrane on the brick, then the wood framework and the insulation put into the framework, then covered with the wood fibre version of plasterboard, and then on top of that lime plaster. I think the biggest issue we had through the whole thing, I'm looking at you because you might know how you deal with this. Can you find a lime plasterer? If anybody here wants a new profession, trained to be a lime plasterer, they're like gold dust. So that was our biggest problem. So that was how we did the walls. We did under the floor exactly the way that Dermot was explaining, although I have to say my husband worked it out on his own, so he was really proud of that. Again, an air tightness membrane made like, we call them saddles, put over the joists, above the air brick, never block your air bricks, but then you're making like a saddle to hold the insulation, and leaving it a bit proud of the joists, because then you get a good seal when you put the floorboards down. We learned about that one because we didn't do it. You had to lift the floorboards up again and then put an airtight membrane down, which we sealed around the edges, just as you were describing. So that was how we did our insulation. And airtightness, just as I said, that's just being so nitpicky, it seems to me, all the membranes, but then really nitpicky about anywhere that you put a hole into the structure that you're building, anything that might let uncontrolled air in. So once we'd done that, we then had to think about how would we ventilate. So we'd got the breathable walls, so we knew that the vapour was going to be managed through all the breathable materials that we used. But we had to find ventilation. In old house, we couldn't have an MVHR like you would have in a passive house, because you need... Thank you very much. Shows how used I've got to it, isn't it? Mechanical ventilation heat recovery system. So you can have a whole house system, but it's got big tubes that have to go between the floors. There's often the space in the loft, but between upstairs and downstairs. And then it takes heat recovery ventilation into every room in the house. But we couldn't do that, and we discovered we've got two different sorts in the house that are single room heat recovery units. So that means that as the stale warm air goes out, the cold fresh air comes in, and as it goes through the tube in the wall, then the heat is exchanged over, and they claim that we save 85% of the heat. So we have these in most rooms. The good thing about these is that you can put them in later on if you haven't got enough. If you feel it's not right or your measurements aren't right, then you can put more in. They go in each room. They can connect up fully. So to me, they seemed like a really good option. Then there was the heat pump, which I don't know if you have a Facebook renovations page around here. We've got one in St Albans. It is magic. Any question you have, somebody else has asked it and somebody's answered. It's fantastic. And there were long conversations about heat pumps and the noise. And were they too noisy, and would they disturb the neighbours? And would your house be warm enough? So our provider was able to take us to another customer who had the heat pump that we were looking at, which was supposed to be the quietest one on the market. And it was very reassuring to see it, well, hear it in action. And we went for it. I have to say, you can see that the square bit is the extension. So we actually spend most of our lives living underneath the heat pump these days. And I don't notice it. The times when you notice it are on really, really cold days when we had snow. Remember those bitter cold days? Then there's a gentle thrum that comes from the roof. It's no more disturbing than any central heating system, to my mind. So if you're getting worried about noise on your ASHP, from my experience, it's not a problem. And we certainly are warm enough. I heard recently, went to visit some friends who live in a passive house, and they said that they've been told that one of the measures of someone who lives in a passive house is they never know what the weather's like outside. And I'm pleased to say we're nowhere near passive house. Of course, we couldn't be. But we never know what the weather's like outside. And I walk outside wearing something. I'm freezing when I get out there, or I'm hot when I get out there. We've got steady state in the house. And as Dermot was saying, on those really hot days last summer, we just battened down the hatches. We opened the doors up about 6:30, 7 o'clock, then battened down the hatches, and we were fine all day. We turned the ventilation units onto boost and just bringing in hot air. And we were fine. So it does, that bigger barrier of insulation keeps out the cold, but it keeps out the heat as well. So where did we get to with it all? This is the new kitchen, which is absolutely gorgeous. I love it, and we live in there. It's an absolute delight. As I said, we're saving 75% of our energy usage. We worked it out on kilowatt hours in the last year before we started any of the retrofit work. We used 25,500 kilowatt hours. And in the 2 years that we've had with the retrofitted house, first year we used 5,200. Last year we used 5,300. EPC has gone from a D to a B, and we had the house valued just out of interest, and one guy came along and all he wanted to know was, where's your internet points? The second guy came along, and his dad was a builder. He understood what we'd done. He was very concerned about the environment. He added another 90,000 to the value of the house. And he said, this will be a house like, we'd made clear we weren't going, but he knew why he was coming. He said this would be a special sale, there would be a bidding war, and it would go above that. So where my mind is now with retrofit is that if you've got your own house, you can do this. And it serves you from comfort, cost, and climate. There's really no good reason not to do it. I can highly recommend it. Thank you.
Thank you so much to both of our speakers for those excellent presentations. Right, we're going to move super quickly to questions because I realise that we're already taking up quite a bit of time and we want to get going. So Gren, where should we start?
Well, Simon needs to join us first.
Sorry, Simon, would you come up and take a hot seat?
Is there any government grants for any of this?
Yes, okay, so let's talk about costs and government grants first. So, someone came up to me before we started with one of these that I think quite a few of you may have had posted through your letterboxes, which talks about last chance to apply for energy efficiency grants under the Green Homes Grant. So that's one of two schemes that are on offer at the moment for getting grants for help with insulation. So the two schemes are, well, firstly, there's a central government funded one, which is called ECO, which stands, in this case, for Energy Company Obligations. So it's basically an obligation that the government's imposed on energy companies to, so from last month, you can now get free loft or cavity wall insulation, and the criteria are you need to own your own home, you need to have an EPC rating of D or worse, so two of those criteria are reasonably easy to satisfy, but the third one, which is kind of means testing one, which is a bit harder, is that your council tax band needs to be between A and D. So it's really just looking at the smaller, kind of, I guess, the cheaper properties within the area. So that's the Eco Home Scheme. So that's free loft or free cavity wall insulation. And you apply for that through an energy supplier. It doesn't need to be your own. So go and look on energy suppliers' websites if that might possibly be applicable to you. The second scheme, which is the one that this leaflet advertises, is run through local authorities. And so in here you've got the badges of all of the local London authorities on there. The Green Homes Grant. And for that one, Barnet is running that. You need to, again, meet three criteria, quite similar. The first is you must own your own home. The second is that you have to have an EPC of D or worse. EPCs, by the way, they're about £90, I think, or £75 to get done. They're not super expensive, if you want to know. And then the third criteria, which again kind of comes down to means testing, is that your aggregate household income needs to be £30,000 per annum or less. Now that occurs to me that quite a few retirees may be applicable, so do have a think about that one. So that's the Green Homes Grant, and if you're interested in more information, then do pick up this leaflet that's probably been posted through your door that's got information, a pointer to where you go, or have a look on the Barnet website for that. Okay, next.
Next question. What can be done about leaded lights?
Okay, the question is what can be done about leaded lights? So our speakers really handily took us through a lot of the larger issues with roof, ceiling, walls, floors, but I guess the big topic that we love to talk about in the Trust in this area is windows, and we didn't come on to that so much in their talk. Okay, let me pass over quickly then to Judith to say what you want to that.
We don't have leaded lights, but we have the sash windows, and what I discovered is, and it may well apply to leaded lights as well, that you can have old windows renovated. So the internal part of the sash, the bit that goes up and down, was taken out of ours, taken away, thoroughly renovated, filled with a double glazed unit inside and brought back and put back in. I don't know whether that would be applicable in leaded lights, but it may be.
So we're going to hand over to Simon.
The other thing is secondary glazing. We've had it for years, and I thought it wasn't of much value, but I got a thermal imaging camera, and it was absolutely spot on. So it's worth it.
Thanks very much. As most of you probably know, there's no problem with double glazing timber windows, either completely replacing them or just replacing the, as you say, the moving sashes or the frames. It does cost more, but a well-made replacement window, double glazed, properly sealed, is very good indeed. There's also no problem with double glazed leaded lights on the rear and side elevations of houses. It's just the front elevation which I think causes a problem, because the front elevations are more publicly visible, they contribute to the streetscape, and their secondary glazing works extremely well. And secondary glazing, I think secondary glazing has a bit of a bad reputation because people think of it as a bit of perspex nailed to some timber and tacked into place. So it's some pretty good secondary glazing that's almost, if it's not invisible, it fits with the ethos of the house. And of course, your secondary glazing could be double glazing. So you're effectively getting triple glazing. You're getting a big gap between the original window and the secondary glazing, and then you're getting the thin gap of the secondary glazing itself. So it's both quieter and heat efficient as well. That's the one compromise. But other windows, all other windows, we can replace with double glazing. And I can never remember its name, but the extremely clever vacuum glazing, which is only available, I think, from China at the moment, but I think there's people looking to manufacture it in Europe, which is the thickness. It's about 8-9 millimeters. You probably know it. I can't remember its trade name, but it's quite expensive. It's about £25 a square meter. Can't remember, but it has the value of triple glazing, and of course, because it's two panes of glass which are vacuum sealed together, it actually fits into almost a single glazing rebate. So it doesn't look like double glazing. I've seen it done. The company I'm using on my own house is in Telford, in the West Midlands, and they use it a lot on heritage sash windows. So interesting to see where that goes.
I think that might be an example of what you're talking about, slim light.
No, it's not. It's actually two panes which are actually, say, glued together. They're vacuum sealed together. So there's no gap. And I should have looked it up before I came out. But it is quite a product, and the technical specification of it does give you a U value about equivalent to triple glazing. Well worth looking at.
Can that be used in wooden frames?
Yep, they are.
Steel frames?
If I could afford it, I would have done it myself in my own house. I've had to go for the Heritage, the 14 millimeter Heritage double glazing. But it does look like, if the price of that comes down, we can start finding some European companies, Pilkington or whoever, to start making it in this country. It does look like a very interesting development, and gets you away from the problem of double glazing, where you've got a vacuum seal which can mist up, and also because you're fitting it into a heritage frames, it tends to be thinner than optimal. The actual gap tends to be thinner than optimal. As soon as I can remember the name, I'll Google it now while somebody else is speaking.
Fantastic, thanks so much. So just on windows, because I know we get loads of questions about it, and there's a lot of misconceptions, I think, about, we just can't do anything with windows because the Trust won't allow us to. And I thank you to Simon for clarifying. Again, to say, I think it's worth repeating, anything within a wooden frame, you can double glaze immediately. It's just a question then of cost. And of course, I suppose things are a question of cost. You then have a spectrum. If you don't want to spend that amount of money, what's the next best thing? Do you go for actually just getting a company like Repair Care, who are very popular in the suburb at the moment, to come and trim and reduce the drafts around your windows, and they also offer a product which is like a laminate glaze that you can put over the windows that has a modest thermal efficiency improvement value as well there. So there is a range of what you can do depending upon how much you are willing to spend, and also how much disruption you are willing to put up with in your homes. It is a little harder, as Simon's mentioned, with leaded lights. We have them on the house that we've just bought on the front elevation. So we're going to secondary glaze there, and then we're going to do sympathetic heritage double glazing for the other elevations that we have. But secondary glazing actually gives you better U values in many cases, so better thermal efficiency at the end of it than the double glazed units. There's just that, as Simon said, they have a slightly bad reputation, secondary glazing. Arguably it doesn't look as nice as the double glazed units, but again, it's kind of a spectrum. It's where you're prepared to go to in terms of your cost and the amount of disruption that you're willing to put up with as well.
The follow-up question,
Yep.
for repeated audience, is would the Trust consider allowing people with steel windows to use different materials?
What, instead of this?
Steel, yeah. Such as aluminium, which is more economically friendly and helps with wood.
Okay, so a follow-up question there, Simon, is, in terms of steel windows, would Trust allow alternative metals or constructions?
I guess the short answer is not unless it looks like a steel window. If it looks like a steel window, then it could be. But as far as I know, there are no aluminium windows profiles which match steel windows at the moment. If something were to come along that did it, yes, if somebody invented carbon fibre window frames that looked like it, at the moment, the later suburb windows are all effectively crystal pattern windows, and steel, which is not a brilliant insulator as we know, is at the moment the only thing that the Trust will consider as an alternative. Which is where secondary glazing might help, because you can put a thermal barrier inboard of the whole window itself.
Just to say that if you do get into the business of taking a window out and replacing it, albeit with the correct sizes and profiles to match existing, it's super important to pay very close attention to the quality of the installation of the window. Massive gaps around windows since time immemorial, and normally they're totally uninsulated, those gaps. So ideally, when you are changing a window, you should air tightness seal that window, so there'll be a tape that you would apply around the junction, and then use the relevant finishes on the outside for weather tightness. And then you would insulate the gap between the window and the reveal, so that that's one holistic solution. And if you do that, around about a third of the heat ascribed to that opening will be lost. So it's not just the glass, it's the frame, and it's the gap and the way in which the window's installed.
Found the name.
Apparently it's Fineo, F-I-N-E-O. Same thermal performance. I mean, I'm reading from this, so don't hold me to it. But I have read their technical briefing, and it is, if it stays on one page, it's roughly the same U value as triple glazing, but obviously effectively one thickness of glass. In other words, there's two pieces of glass, but there's no gap between them.
Are any of your registered, please?
Fineo, F-I-N-E-O.
Any of the approved Trust installers offering that product? No.
I don't know. So the people. It is. Sorry, I'm not going to advertise, but it is sometimes. We don't have a list of approved installers. We have a list of installers who've done work on the suburb. That doesn't mean you can't go and find somebody else. There are lots of good people outside London who regularly work down in London, and it may be worth looking wider to find the companies which offer these special products, rather than going to companies who are dyed in the wool, producing the windows they've always produced. Window technology moves on, and there are companies which are beginning to embrace that challenge of working in Grade 1, Grade 2 listed properties, National Trust properties. The company, as I said, I'm personally gone to, does most of its work for National Trust properties. So they're looking for replacement windows which literally must look the same, where double glazing itself won't be accepted. So it's worth looking wider, looking at the companies which are at the leading edge, rather than just the same old companies where perhaps you see around the suburb. Here endeth the advert.
I would just add to that, as someone who's recently kind of gone through this process and discussing with you and your colleagues at the Trust, there is an extra hurdle if you don't use somebody who's already on the list, because you need to provide not just the application but also the samples.
You do need to provide a sample.
Yeah.
You do need to provide a sample, but I guess again there's lots of different ways around that. I don't think the Trust isn't looking for sort of a a 6 foot high by 4 foot wide sash window as a sample. There may be other ways of doing that. But as you said in your introduction, if you're contemplating something like that, come and talk to us to start with, because you may have come across something we haven't found yet, in which case we'd be very keen on working with you to see how we can get the best, both the best for you and maybe something that we can adopt ourselves.
Thank you so much.
Just a comment.
Yes.
I've seen in the suburb people who've used blinds, which is just see-through blinds, on railway, on a track, and it does stop it's like a curtain, but it isn't, and it's hermetic, and it's very nice, and it's inside the house.
Can I just say something about inside? I think in your introduction you may have said that, I may be remembering it wrongly, that you would need permission from the trust if your house was, to do internal work if your house was grade 1 or grade 2 listed. That's not actually the case. The trust has no controls over the inside of houses at all. You'll need permission, listed building consent from Barnet to alter the inside of a listed property, but the trust has no controls over the insides of properties. So blinds, curtains, internal wall insulation is not something that the trust has a control over, and it doesn't wish to interfere in that respect. It's only if it's externally visible.
Thank you. Thanks for the clarification.
Next.
Yes.
Floors.
Floors. Let's do floors next.
So Judith lifted her floor, but what happens if you've got a concrete floor or a parquet floor like this?
Yes, so Gren's just asking a question. We're moving on to floors now, and solid floors versus suspended floors. So both of our presenters showed slides that showed suspended floors. There is a mix, we believe, within the suburb between solid, just because of the point at time at which many of the houses were constructed in the 1920s and 1930s was the real tipping point in terms of construction methods, and that's between solid and suspended floors, and also for walls between solid walls and cavity walls, which we'll come on to shortly. But talking about floors first of all, yeah, what happens? Any of our speakers able to talk to us about what we do if we've got solid floors instead of suspended?
So there's two choices. You either plant insulation and flooring on top of the existing slab, in which case you've got skirting boards, door heights, and architrave issues, as to say nothing of all your furniture. So that's the obvious immediate thing you can do. There are also composite flooring products that have got insulation on them, on the underside of them, but all of that's going to raise your floor, essentially. And of course the other approach, again equally obvious I suppose, is you dig up your floor, reduce it, put some insulation in, and essentially reconstruct the floor to accommodate an insulation and ideally an air tightness layer as well, and then rebuild on top.
Thank you. And can you give us an idea? I mean, the slide that you showed us, which talked about the old Energy Savings Trust slide that showed us the percentage of what you would expect in terms of heat loss percentage through the floor. I seem to recall was only around 8%. And is that less with a solid floor? I had the impression that actually, especially in parquet floors, it's not a bad insulator. There's no real reason, of all the things you could do, actually the floor is maybe the one that you want to do last because it's not actually the greatest source of heat loss in your house.
It's certainly, well, almost certainly the most disruptive thing that you're going to be doing, because everything, you have to void the space, in order to be able to access the floor. And to do it properly, you have to be fairly comprehensive, so you need to go, all the way across the floor. So there are two issues with the floor, as with all the other elements. One is the heat loss factor, and the other is the draft or air admission factor. So with a concrete floor, typically with some sort of a timber on top of it, followed by skirting boards, you're going to have much, much less of an air tightness issue. But clearly with a suspended timber floor construction, you've got the two challenges: the heat loss through, maybe 18 or 20 or 22 mil of flooring, and then you've got all of the drafts. So those are the two issues, and it's important for all the elements to consider those two issues. It's just not the heat loss, it's also the air admission.
Just one comment. If you've got a suspended floor, from our experience, I think it was the most important thing that we did, because it was freezing. The coming up, if you think you've got the air bricks and it's coming up through the floorboards, it was freezing. It made a huge difference.
Thank you. And a rule of thumb, if anybody doesn't know whether or not they've got suspended floors or solid floors, a really good way of testing is go around the outside of your property, and if you can see air bricks, then you have a suspended floor, but if there's no air bricks, then the likelihood is you've got a solid floor. And just to reiterate, to jump on what Judith just said, in the current refurb project that we're doing right now, we have a suspended timber floor, and we are taking advantage of the fact that we are going to put insulation in there to also put down underfloor heating, which works excellently with an air source heat pump. So if you're thinking about doing one, then do look to do both at the same time. Great. Bren, what should we move on to?
How do you find good builders and architects who know about this kind of stuff?
Judith, do you want to talk to that?
You need to repeat the question.
Oh, the question was, how do you find good builders and architects who know about this kind of stuff?
With difficulty, is what I would say. Very, very, very difficult. I think, and I'm delighted to hear about the work you're doing, because it seems to me we're on a bit of a cusp, that there's lots of architects who are trained to do passive houses, which are the big sexy things, but I think that to find people that will really know what to do with retrofit, and particularly to do it with eco-friendly materials. We've got builders in St Albans who claim to be doing retrofit, but they're using PIR and petrochemical insulation, and it's really not what I would think of as retrofit. So if you find them, pass the name on, it's gold dust, and find a lime plasterer while you're on the way.
Yeah, this is a huge challenge, and there's an enormous deficit, not least after Brexit. A lot of the skills base in the construction industry left the country, and unfortunately, since that time, with COVID and all the rest of it, there's been massive price inflation in the construction industry. And just to give you an anecdotal example, about 3 years ago, I was procuring an £8 million project to retrofit about 100 homes to net zero for a London borough. And the very first procurement went out, an expression of interest, if you like, stage, and we got across, I don't know, 30 or 40 national building construction companies. We got one reply, just one reply, and that was an £8 million pathfinding retrofit project sponsored by national government, local government, regional government, huge acclaim, huge publicity value, and we got one single tender reply. Now that's changed in the last 2 years, and there's a very large and very creative procurement going on at the moment through the GLA for regional local authorities to procure, to basically amalgamate and put together in one pot a huge big stream of retrofits over the next 5 years. So building a pipeline, which basically means there's demand and that hopefully gets met by the supply side. So that's happening, and there's a knock-on effect. This is going to get easier, and the knowledge is improving all the time.
Could I just reinforce my colleague's messages here? At the Trust, we're always intrigued that people will often spend a considerable amount of money on major works, but not actually a proportion of that on getting good design advice. Although a good designer, including good environmental engineers, come at a cost, it's only a fraction of the cost of the building work. And having that person in place, and having that person in place all the way through, is never money wasted. So it's worth, it may be difficult finding them, but I think it's worth going out and tracking down, as you said, Judith, tracking down the right people and then hanging on to them and then passing their name on, please.
That was the other thing I was just going to come on and say, that I think we put a shout out recently.
Microphone switch, I think.
Better?
No.
Better?
Yes.
Sorry. We put a shout out recently asking for any local recommendations of people who were into these kind of eco technologies, and builders, architects, installers, heat pump engineers, blah, blah, blah. We didn't get very much response, and so we'd be really keen to hear from people who are having positive experiences so that we can build that network. So, I'm having a really great experience with the experts that I'm using at the moment. I'm happy to share them. But yeah, we just need to start sharing that knowledge. I'm looking at Rosemary. I know who's just recently gone through it.
Unfortunately, we have not had an untroubled path. We've had an architect who has been completely clueless. We've had a good installer we're putting in an air source heat pump and underfloor heating. We had a good installer, but there has been a critical issue which was not picked up by a series of people, and nobody feels it's their, well, no, the architect feels it's not his fault. And there is this lack of knowledge and this lack of keenness for architects, I would say in particular, to continue their development and move into the 21st century and realise that they actually should be aware of what the substructure should be, and generally improve their knowledge base. And I think that's rather sadly lacking. So at the moment I think there's a really big need for education in the building profession between architects, installers, builders, and for them really to share their experience and learn from their errors.
Yeah, I think hopefully, as Dermot says, that body of knowledge is growing all the time.
Yes.
And we were just talking last week in our REACH meeting amongst the committee how we would really like to perhaps put on a talk just for architects to try and encourage and educate, and then that means that when you, the residents of this area, go to them, and sorry, it's so late now, everybody, do apologies if we've overrun, but if you need then to look for expert advice, hopefully there'll be more of them around who have who've got the knowledge.
One quick, sorry, 2 quick points of practical import. If you are engaging anybody to do renewable energy technologies, so air source heat pumps or solar PV or solar thermal, whatever it might be, it's really important to use an MCS registered installer, and also to use somebody who is subscribed, a member of the RECC, which is the Renewable Energy Consumer Code. And this means that you've got some guaranteed protections if things go wrong. On the practical end of the construction side, there's an organisation called the Green Register, which I would encourage you to look at. They have a register of professionals who work in the space, and also another organisation called the AECB, which is the Association of Environmentally Conscious Builders. And these people, amongst several others, have got reference lists. So they're good places to start with, and there are others. I'm just not thinking immediately of what the others are, but those are good starting points.
Thank you very much. Right, shall we move on to another question?
That was the last one?
Yep.
Probably the most representative would be what is the Trust going to do to help residents? It's a bit of a pointed question.
Did you hear that, Simon? I'm going to repeat it for the audience. So Gren's trying to take kind of broad themes of what the questions have been asked, and the feeling is that the question or the sentiment is, what can the Trust do to help residents?
Within the limitations that the Trust has to work, and those limitations are given to us, is try not to get in people's way when they need to do this work. So the first way is to work with you on it. There are a goodly percentage of properties on the suburb that could have major work done to them that nobody's applied to us for. And we're always surprised that we've had so few applications, where the more applications we get, the more we can all learn together how we can actually overcome these. So, for example, we do actually have an external wall insulation application at the moment. We don't know whether it's going to work. I think I share your concerns about the technical abilities of some architects, but they're going for it. And we're trying to help them and work through together to see whether it can work. The more we do of these, the more we'll all learn about what's possible and what's not possible on suburb homes. There's a number of suburb homes that have solar PV installations on them. There's a huge number of suburb homes that could and don't. Where's the gap there? There's, as I said, internal insulation is not the Trust's remit, so that's an open door, as is underfloor insulation, as is loft insulation, as you said, although you need Trust permission for it, replacement windows. There's a whole load of things that can be done, and yet we don't see very many applications. So if you come to us, even before an application, and say, I'd like to do this, we will try and work with you. So that's one way of helping, I think. I think sharing knowledge is another thing. We're on a learning curve too. Everything I've learned this evening, I've taken lots of notes, I'm going to go away and pass them off as my own. No, I'm not, don't worry, I will very gladly. But we're all on a learning curve. So I think once we learn something, we'll also adapt our guidance. And we'll try and pass on. I think you're doing fantastic work here in Reach. So working together with the RA is one thing we can do together. We are constrained in some respects by the remit we've been given by the scheme of management. But within that, we're trying to find ways forward that will enable residents to bring their houses up to the level, getting near the level of insulation that can be achieved. Each house is different though. There are plenty of examples on the suburb where there are semi-detached houses, two houses joined together, where one half, or what's possible on one half is not on the other. So we shouldn't make generalizations. Each case is unique, although there are some general principles that can be applied. Please come and talk to us. We are open. We're very happy to engage on a one-to-one basis.
Thank you so much, and I just echo that that's definitely been my experience over the past few months as we've been talking, that the Trust is very responsive and very keen to have questions. Yes, I can see it. Desperate.
Is there an example of a single property in the Trust, in the suburbs, that has met the net zero target? Is there an example that's been approved by the Trust that we could all potentially take, an example plans or work towards?
I'm looking for Gren in the audience. Oh, Gren, what do we have any properties at the moment that we're holding up as being our flagship properties that people should be trying to emulate?
I thought we were going to use yours.
We are, but it won't be ready for another couple of months. But actually, on that note, so seriously, my refurbishment that we're doing at the moment, we're going to be putting solar on our house. We have a flat roof, and so we're able to do that. The Trust is not currently amenable to applications for solar on any pitched elevations, but if you've got a crown roof or a flat roof, you can make an application for solar. We're going to be putting an air source heat pump in. We're doing that in conjunction with a large refurbishment of the property. I mentioned earlier we are double glazing all of the side and rear elevation windows with secondary glazing, the leaded lights on the front. We're doing thin internal wall insulation throughout using a breathable product called aerogel. We have some samples at the back if you would like to take a look at this NASA space age technology of aerogel, and Dermot has kindly brought along some other really breathable, great solutions for thin internal wall insulation. We couldn't do external wall insulation on the house. It's a brick kind of herringbone mock Tudor construction, it wouldn't be suitable for external wall insulation. But that said, it's interesting that you mentioned that there's an external wall insulation application in at the moment. Can I ask, is that a pebble-dashed house?
It's a rendered house.
It's a rendered house. I was going to say that is one of the, and actually a surprisingly large percentage of the houses in the suburb are already externally rendered. So external wall insulation is something that you could look at there. I'm not aware of any other applications that have previously gone in for external wall insulation, but that is something that we would love to hear from you. If you're interested in that, please do share. We're also doing underfloor heating in a suspended timber floor and insulating to the max there, and we're insulating at the roof level because we're having to re-roof the house anyway because the tiles were in a poor condition. So we're taking advantage of the fact that we needed to refurb the whole house to just do the full I'm very happy to share my personal experiences of going through the process and also to kind of open up to an open house afterwards to have people come around and see what we've done and what you'd like to know, and you can hear that noise of the air source heat pump and decide for yourselves if that's, you know, that's the right technology for you, and ask those kind of questions. And if anybody then is inspired to go through it themselves and wants to again share, then please do that, because I think, you know, I'd love for this all to be a collective effort. We all need to do our own part to help us all get there by 2040, not 2050 is our aim. So shall I pause there to say thank you, huge thanks. Of course you can. But say thank you so much to Simon Henderson for joining us and for stepping in to very grateful, thank you. And to Dermot also for coming to give us his talk. And to Judith, who quickly wants to say 2 words about her book.
Yeah, I just wanted to say part of my response after finishing the house was to write the Idiot's Guide book that I needed in order to help us do the work. It hasn't got all the answers, but it gives you enough information so that you can ask the right questions and have a good conversation. All the money that I make from it goes to Friends of the Earth to continue the work. So if it's any use to you, I've got some here that we can sell. If you know of anybody that might be interested, please pass it on. This is my climate action at this stage of my life, so please make use of it.
Thank you all for coming.
Thank you very much, Sarah, for leading that session so well. And Tony, thank you for all your high technology stuff over there. Just next time, could you move the pipe, please? Just a couple of feet to the higher up. So lots to take in and lots to think about. No magic solutions. Just one thing I would like to add. We've got the stall out there from the company who have installed solar panels in several places in the suburb, including on my next door neighbour's roof extension. So they've come along specially to deal with any questions you might have on what you can think about doing there, and some big kits in ways you can actually store daytime energy to use at other times as well. So thank you all very much for coming, and we will be doing another meeting in June around green investment, and we've got some external speakers coming along to that, and we will be promoting that very shortly. So thank you very much, and thank you to Bren and everyone else who came along this evening. Thank you.